Looking at number 1 on the semester review. Again, this section is with calculator. Doesn't mean you'll need your calculator, but it means you've got it if you do need it. So we make a first pass through. We're done with calculus. Now it's a matter of algebra to get dy dx by itself. So let's see, 12x squared minus 6xy dy dx minus 3y squared plus 3y squared dy dx. Okay, again, I'm looking at those dy dx's.
Okay.
Yes.
So with the x 2y, how does it then become negative 6xy when you multiply it by the negative 3?
So I'm multiplying this to all of this. So the negative 3 and the 2 give me the negative 6. There's still an x, there's still a y.
So it's okay that it moves out to the front of the...
Its multiplication doesn't matter really what order.
Okay. Yeah, okay. I'm realizing that now.
It's okay.
Like my brain was like that. Maybe I was thinking like dividing.
So I'm trying to save space and time here. I'm going to move those two things to the other side. So I'm going to have 3y squared minus 12x squared if I move those over. If I'll add 3y squared to the other side, I'll subtract 12x squared to the other side. And then I want to factor out dy dx from what's left. I'm also going to rearrange the order so I put the positive one first, just because it looks better. 3y squared minus 6xy. So I guess that was just 2 steps, maybe 3 steps. Move stuff over, rearrange things, and factor out dy dx. That's a lot in one algebra step there. So are you okay with that? Because I think it's easy from here. We'll just divide by the stuff that's attached to dy dx. So 3y squared minus 12x squared over 3y squared minus 6xy. And, well, I have a calculator, so I could just go ahead and right now and plug in 3 and 4. I think when I worked this problem, I didn't have my calculator with me, so I divided everybody by 3 to make the math a little easier. But you got a calculator, so why not use it? Let's see. 3 times 4 squared minus 12 times 3 squared over 3 times 4 squared minus 6 times 3 times 4. Oh, that's kind of cool. My calculator recognized that I was trying to put in a fraction, so it gave me a fraction as an answer. 5/2.
Okay, this is off topic, but the derivative of cosec, is that negative cosec cotangent?
The derivative of cosecant. Let me back up because I don't really know that one. I know derivative of secant is secant tangent. So the derivative of cosecant is negative cosecant cotangent, and I think that's what you said. But that's a good example of one I don't have memorized. I have the secant memorized, and then I can figure out the cosecant from that one. Other questions from the semester review? Page 1 and 2.
6.
Which one? 6.
What are we supposed to do there?
Use the table at the right to answer the following question. If f is continuous and differentiable, then approximate approximate the value of f prime at 3. So f prime at 3 is the instantaneous rate of change, but I don't have enough information to get that, so I will approximate it with the average rate of change. Now at 3, I don't like this question because it's not clear. Should I do... No, it's definitely clear I have to do AROC. I can't do IROC. I don't know what's happening exactly at 3 in terms of slope. But I don't know whether to use 2 and 3 to estimate the slope at 3, whether I should use 3 and 4 to estimate the slope at 3, or whether I should use 2 and 4 to estimate the slope at 3. And I don't like this question because you don't know which one to use. So I guess we'll start by using 2 to 3. So that would be, again, this is just algebra slope formula here. 2 minus 4 over 3 minus 2. So that would be negative 2. That's not even an answer choice. So let's try 3 to 4. So that would be 5 minus 2 over 4 minus 3. That would be 3. Also not an answer choice. So I guess we'll try 2 to 4. There's just no way to know which one is the best estimate. The left side, 2 to 3, the right side, 3 to 4, or sort of this whole thing, 2 to 4. 5 minus 4 over 4 minus 2 would be 1/2, and that is a choice. Again, I don't like that problem because it doesn't tell you which way to estimate it. How they usually would be asked is estimate. So a better question would be estimate f prime at 5.5, because then there's no doubt. We'll call this 6b here. In fact, why don't you do that? Why don't you estimate f prime at 5.5? Only one thing I would maybe tweak about my answer. F prime is not equal to that. F prime is approximately that. Now, that wouldn't matter on a multiple choice test, but on a free response, even then, that would be pretty picky to take off for that. Also, this would have been a safe stop right there. But multiple choice tests, they usually don't leave safe stops as answers anyway, so.
But wouldn't you just assume to use 2 and 4? Because 3 is like in between them. So wouldn't that just be like, that would make sense to use that first one?
Yeah, but you, depending on what the problem looks like, it might be that 2 to 3 is a better estimate for the slope at 3. Let's say this is 2, this is 3, and well, I'd have to make it even steeper than that. Let's say it does this. Well, the actual slope at 3 would be best approximated by the slope from 2 to 3, right? The slope from 2 to 4 would be way different. But that depends on the picture, so you don't really know. You don't really know. And for that matter, all we have is 2, 4, 3, 2, and 4, 5. So approximating this slope by using these two, well, I have no idea what this graph looks like. I mean, it might even be like negative slope there, and then it turns around. So this approximation could be way, way off. We just don't know. Other questions? Which one? 4? Yeah, 4 is a good one. 4 is definitely a calculator one. the first derivative of the function is given by. Okay, so we don't really know if this is good news or not, but it's giving us f prime, so I probably don't have to take a derivative. Like, that is the derivative. How many critical values does f have? So critical values of f would be f prime equals 0 or f prime undefined. Have on the open interval 0 to 10. Well, so I want to know where it's equal to 0 or where it's undefined. Let's do the undefined one first because I think that's easier. Where would this thing be undefined? What value of x would make this a problem? 0. Okay, now let's be super careful. That's true. 0 would make this expression undefined. Are we going to count x equals 0 as one of our critical points? Why not? Because it's not in the interval. So yes, but no, right? So, but not in the interval. So I'm not worried about x equals 0. I'm worried about the places this function's equal to 0. Sine of x. Careful with parentheses and squareds. Over x minus 1/9. And it said to look from 0 to 10, so I'm going to go ahead and make my window. I'll go -1 to 11 just to make sure I see everything. My y min and my y max don't matter too much. I just need to make sure I see 0, the y axis in there. Uh-oh, I know what I did wrong.
Like 0.2 and then like 1 or something for like a y.
You guys probably haven't done enough of these to recognize what error I made when my graph looks like that. But I've made this mistake often enough to know what just happened. I'm looking from 0 to 10, but 0 to 10 degrees is not very much. I need to be in radians. In calculus, you're always in radians. You don't have to worry about that. The trouble for me, here's my excuse, is that pre-cal is a lot in degrees right now, so if I grab a pre-cal calculator, might be in the wrong. That's still not very helpful. What do I need to do to be able to see those zeros better? Yeah, I need to kind of zoom in on the y, so I need my y min and my y max to be a lot closer. Let's see if...
Like 0.2 and then 1.
Yeah, I'm trying -0.5 to 0.5. Let's see. Man, I'm still not sure if that's a bounce or a cross right there. We'll just go -0.1 to 0.1. So I'm looking for the places it's equal to 0. I'm really worried about that one. Second calc 0. And I don't care what they are, it's just a matter of counting them, but I need to see if that's really one right there or not. There it is. Left bound, enter, right bound, enter, guess. So there is one at 0.11. So that's 1, 2, 3, 4, 5, 6. Which means I think the key was wrong because I didn't look close enough. So 6 times f prime equals 0. So that means there are 6 critical values of f on 0 to 10. Man, we had to look close, and that's not including 0, right? So 1, 2, 3, 4, 5, 6. And you can see from the graph that 0 is undefined. This heads toward an asymptote thing, but that's why we didn't include that one.
Just as like a refresher to find those without the calculator. I understand like this question just had weird values and stuff. you just set the derivative equal to 0.
Right. You'd set it equal to 0 and solve, but I don't want to do that with this. Yeah, I don't know how to do that sort of, algebraically. I guess you could multiply through by 9 and by x. But that still doesn't, I still can't solve that. That might have been easier to graph, but go ahead.
Number 7, okay, like, you consider it and it could be like, it's like close to B or D, but it's not.
Given f prime from 0 to 0.7, at what value of x is the tangent line horizontal? Tangent line horizontal, what's that mean? Oh, sorry. So what does tangent line horizontal mean? F prime equals 0. So I'm going to type this into the calculator. That'll go into y1 in the calculator. And then we'll just look for where it's 0, between 0 and 0.7 anyway. Oh, calculator usage. 2 sine of 2x to the 4th. That's... Do you know if that's raising 2x to the 4th or sine to the 4th? It's actually raising sine to the 4th, but if you're not sure, it's probably safer to make sure. Now I know the sine of 2x is getting raised to the 4th. Minus 3 sine of 4x to the 3rd. Again, this is why you have more time per question on the calculator part of the test, because it takes a little time to type this stuff in. Window, it told me to look between 0 and 0.7. And I only want to know where it's equal to 0, so zoomed in at from negative 0.1 to 0.1 is probably fine for the y. Goodness, it's thinking hard on this one. Oh, there we go. There's my answer. Now I need to figure out where that is. Second calc 0. If the cursor is not on the screen, it's maybe hard to figure out which way to go, but it tells you that x is 0.4. That's where my cursor is. I know this is 0.7, so I probably need to go to the right to get there. Up there it went.
Okay.
Left bound, right bound, guess. 0.567. And there it is. That's also the importance of using calc 0 rather than trace, because trace you might have ended up at 0.55 and thinking that was closer. But you don't use, nothing wrong with trace, but it doesn't tell you where 0 is. It kind of gets you close. By the way, 7 and 8 go together because that's the same function. Do we need to do 8 before we go on?
Sure.
Okay.
Oh, fine.
Given f prime equals, okay, so that's the same thing. At which value of x from 0 to 2, so I got a new window here, I need to be careful, does the graph of f have a relative minimum? F has a relative minimum. Okay, so forget this problem, forget the details of this problem. When does f have a relative minimum? Wait, when f prime, so yes, when f goes from decreasing to increasing, but that means when f prime goes negative to positive. So I'm going to look at my graph and find out where f prime, which is what I have the graph of, changes from negative to positive.
So do we need a y2?
No, the function they gave us is f prime. So I'm looking at a graph of f prime, and I want to know where it changes from negative to positive. It's the same spot. They asked the question differently, but it ended up at the same answer.
What was the values that you put into the window?
They told me to go 0 to 0.7, and I just zoomed really close in on the y. And I mean, maybe I'd get a better picture if I didn't look so zoomed in on the y's. And for this one, I was supposed to go 0 to 2.
Oh, yeah, that is the.
So, but there was only one answer, so once I saw it, I didn't have to worry about. I wonder if there's, yeah. So the reason they went 0 to 2 is to get that one on there. What's happening on the graph of f at this spot? This is the graph of f prime. What's happening on the graph of f at this value of x? That's a max, because f prime changes positive to negative. So f has a max at whatever that is. My guess is that's, oh no, that wouldn't be right either. That's probably 1.571 is right. Is that point. So for people who got the plus minus thing backwards. No one has asked, but number 9 is definitely a no calculator question, or a no calculator needed type of question. And it's the old stuff. So are we okay with that? Have we done enough of that recently to be good? No? Limit as x approaches 1 exists. True. And what is the limit equal to? If it's true, then what?
Is that just the answer? It's true.
Yeah, it just says true or false.
Okay.
But just for practice, the limit as x approaches 1 is 1. Limit as x approaches negative 2 exists. True or false? True. And what does that limit equal? Would be 4. So there's a hole there, but that's okay, because it doesn't say the function at negative 2. It says the limit as we get really close to negative 2. As opposed to, what's f of negative 2 equal to? What's the function at negative 2? It's a separate question here. 3. So limit versus function, hole versus dot.
Is there only one false?
I don't know. Let's see. Part C. F is continuous from negative 1 to 4. Negative 1 to 4.
Oh wait, no.
Is that true or false? Continuous from negative 1 to 4. So that means I don't have to worry about the hole. It's trying to make me worry about the cusp, I guess.
Mm-hmm.
Is it continuous at the cusp?
Yeah.
Yeah. That's true.
And then D would be false.
F is differentiable from negative 1 to 4. What do we think about that one? False, because of the cusp. So it's continuous at that cusp, but it's not differentiable at the cusp. Right? There's no way to find the slope at a pointy spot. You couldn't draw a tangent line right there. F is differentiable from negative 3 to negative 1. What do we think about that one? False. That one actually has 2 reasons.
The whole.
There's a hole, so that would be a problem. Or it's a cusp, so either reason would be sufficient to say that there's not a derivative. Well, we've done almost all of them. Oh, the only 2 we didn't do were the 2 related rates problems?
If we're running out of time, you don't have to do the whole thing, but a review on related rates is much needed, just in general.
In general. Let's do number 5 because I think it's easier. And then we'll do number 3 after that. Or,
3.
Do
Do 3.
3.
okay.
3 was.
3's the hardest one, for sure.
Yeah.
2 I don't think is bad. 5's probably the easiest. So it's probably 5, 2, 3, going from easy to difficult. let's see, a 25-foot ladder is sliding down a wall. Okay, don't even do 5. Just do 3. Do 5?
No.
We have time to do both.
No, do 3 first, then 5. Well, he thinks we should do
5's the reminder of how things work here, and then we'll do. Let's do 5, and then we'll do 3. The 25-foot ladder. So the ladder is 25 feet. And the ladder is a fixed 25 feet, right? It's not like a collapsible ladder. The ladder is staying 25 feet. So the base is moving along the ground at 3 feet per hour. That's really slow, right? So I'm going to label those A and B because I'm kind of already thinking A squared plus B squared equals C squared. So what is 3 feet per hour? So that's how A is changing. Is the ADT positive or negative? Positive. It's sliding down the wall so that A is getting bigger. When the ladder is 10 feet high on the wall, excuse me, so when B equals 10, how fast in feet per hour, so that's a rate, that's a d something then, that's a derivative of some sort, is the top of the ladder moving down the wall. So find dB dt. Is dB dt going to be positive or negative? Negative, right? As this thing goes down the wall, B is getting smaller, A is getting bigger. B is negative. Is there any I could throw out? I could throw out D and E. So at least I'm guessing 1 out of 3. I'm guessing it's probably not A because A is how fast A is changing. So that seems pretty doubtful. But it just seems doubtful that they're moving at exactly the same rate. Yeah, so maybe we'll see. A squared plus B squared equals C squared. So 2A dA dt plus 2B dB dt equals 2C dC dt. We know C, a little inventory of what we know. When B is 10, so we know B, we're trying to find dB dt. We don't know A, but we can find A, right? A squared plus B squared equals C squared, so I can find A. 25 squared minus 10 squared. Second square root of that. So A is 22.913. So I know A. I know dA dt because they gave that to us. So what's the only thing that we don't know that we need to know? Okay, so yeah, we're trying to find dB dt. What about dC dt? Didn't tell us what that is. C is constant. So what does that mean dC dt is if C is constant? 0. It's not changing. How fast is the ladder changing? Well, it's not. This isn't a collapsible ladder. That would be a more complicated problem, but we don't have to worry about it. So let's see, how much algebra do I want to do at once? Probably not too much. I can divide everybody by 2. Make life a little easier. So B dB dt equals negative A dA dt. At some point I need to start plugging things in. dB dt equals negative A over B dA dt. So negative A was 22.913. B was 10. dA dt was 3. So we will get a negative number out of that. 22.913 times 3 divided by 10. And I know it's negative, so B. Okay, now number 3. Anything else on 5? Now, obviously that was a calculator question, and it would have had to been a calculator question. You could make it a non-calculator question if you'd have made the values a little easier. Like if we'd have made this a 3, 4, 5 triangle, if we'd have made some of the values simpler, then you could still have a no calculator question that was based on the same stuff. Number 3. A container has the shape of an open right circular cone, as shown. The height of the container is 10 centimeters, and the diameter of the opening is 10 centimeters. Water in the container is evaporating so that its depth is changing at a constant rate of -0.3 centimeters per hour. So what variable is that? What? Look at the units. Units is not volume, and it tells us its depth is changing. So that's dH dt. They conveniently give us the volume of a cone. Find the rate of change of the volume of water. So that's dV dt. With respect to time, so dV dt, when h is 5. Indicate units of measure. When it says indicate units of measure, that means there's a point attached to the unit already. Well, I can give you the units of measure already. Volume per time is going to be centimeters cubed per hour. So how about that? That just got me a point on this question without really doing anything. Okay, V is 1/3 pi r squared h. If I take a derivative now, what do I have to use? What am I going to run into? The product rule, because I'll have r squared and h in there. It'd be really nice if h and r were related to each other, and that way I could make one of them go away. That's why it gave me these overall dimensions. R and H. Is there a relationship between R and H? Yeah, 2R equals H. Wherever we go, however much liquid is in there, like similar triangles kind of a thing, it's going to take 2R to equal H. Okay, so do I want to plug in 2R for H? Or do I want to plug in H over 2 for R? Which one would you rather do? But use this to make your decision. I want dH dt to show up because I know what dH dt is. So I need H's in my problem. I don't want R's in my problem. So I'm going to replace R with H. So mathematically it would be easier to do it the other way. But if you do it the other way, then you have dr dt, and you don't know dr dt. So it's best to replace the R's. 1/3 pi h over 2 squared times h. So a little bit of algebra, not even algebra, I guess it's algebra. 2 squared is 4, times 3 is 12, so pi over 12 h cubed is the volume. So dV dt is 3 times pi over 12. Whoops, that would reduce, but we'll get that later. 3 times pi over 12 times h squared. Is that my final answer for dv dt? Answer is no. What am I missing? What did I leave off? dh dt. It's like a chain rule thing. So dh dt. And we're looking for dv dt. We know h. We know dh dt. So we're good here. Heck, if I really want to be lazy, there's my answer. I already said centimeter cubed per hour, but may as well put that on there. And it's a calculator question, but it didn't have multiple choice answers, so leave it. Why risk it? That's the answer. If you want a better answer, type it in your calculator and figure it out.
Is H and
Okay, so be careful. H is 10 for the container, but the level of water is 5 because it's falling. So that's a good question, and maybe I shouldn't have labeled that H equals 10. Maybe that's why they didn't label it H equals 10, because H is the height of the water. Let's see, dv dt would be negative. Let's see if that makes sense. Oh yeah, if water's evaporating, then we got less water. So yes, I believe that. And similar, if depending on how the question is asked and what the answer choices were, this could be a multiple choice, no calculator question. Probably wouldn't be, but you could make the values easier, or you could sort of leave that as your answer, or you could word the question differently to turn it into. Basically, I don't want you to say, oh, that's a calculator question, I don't need to worry about it. Like, no, AP can always come up with a way to ask a question that doesn't require the calculator. At least it covers the same concept.
the test tomorrow is no calculator.
Correct. All of our test is no calculator. Tomorrow and Thursday. Tomorrow's multiple choice. Thursday is the free response. With the big curve attached to it. 3 times 9. This is me doing my homework here to figure out what each multiple choice question will be worth. That'll be fun to keep up with. And so you'll get a grade out of 54. I'll turn that into some percentage. And then I'll add 25. And that'll be your gradebook grade. But this percentage is what I'll use to so what did I say? Usually a 50 corresponds to a 3. So a 50 to a 60 will give you a 3. 60 to a 70-ish gives you a 4. Greater than a 70 will be a 5. And I don't really know the breakdowns lower than that because we're not really worried about it. I'll probably just do it the same way. 40 to 50 would be a 2, and less than 40 would be a 1. But that doesn't go in the grade book. That's just for you to kind of think where you stand. Mark?
Multiple choice on this test going to be like the other tests where we can get partial credit on it?
No, it's not. But the trade-off is you're getting 25 points back at the end. So it's...
That doesn't make me sound like a slacker. When you're really good on this, do you think the semester final is necessary? Like, even as practice? Because this seems like a semester review.